study, and actually, we're going to be doing it for several weeks. A case study um, is what architects and engineers use to research um, what they have yet to design. So, like if they never designed a bridge or a library or a movie theater or a bowling alley, um, they'll do a case study. And what a case study is they'll study um, bridges or movie theaters, bowling alleys that have already been done, by other people, and they'll study the successful ones, and they'll study the ones that have failed sometimes. But here we're going to study some of the most successful concepts, so you can better identify um, what you should be um, designing and what you're going to get into. And so um, you can justify your design choices by looking at successful designs and saying, hey, this design works really well because it works over here. And when I paired it with this other design, it worked well over here as well. Um, and so that's basically what we're going to do. And so we're going to go through that together. Um, and so how you really start is the architects and engineers start with the occupancy type of the structure. And I know that's a fancy word, but really it's talking about the occupants, who is going to be inside these structures and the type of use of the structure. So whenever you see the word occupancy, it is referring to the use of the structure, who's using it and how it's being used. So like a hotel is a different occupancy than um, let's say like a movie theater. So only a certain amount of people can, be in a hotel versus so many amount of people can be in a movie theater or a school or a house or a bank. Um, there's only so many amount of people that can go inside a particular building before it's deemed unsafe. And it's deemed unsafe not because any one particular person says so. We collectively, as a society, got together and came up with building codes. And these building codes are basically laws that govern how architects, engineers design, and builders build to ensure that people are safe and the well-being of um, the people using the structure are being the engineers and architects are mindful of the people that are occupying the inside. So um, it's really referring to the function of the space inside. So like I said, take the house for example. When you read this, there's public areas, there's private areas, there's circulation areas where public areas are like your kitchen, living room, dining room. Private areas, bathroom, bedroom, powder room. We do private things. Circulation areas are paths of travel for people to get from one space to another. So like when you go from the living room to your bedroom, you might go through a hallway. And that is considered circulation area. It's no different from any other spaces. It's, you know, private areas and commercial spaces as well. So like if you go to like a Target or any store that sells stuff, they have private areas for changing rooms or bathrooms. They have restroom areas. Those are private areas. They have circulation areas. Sometimes you have to go down a hallway to get to the bathroom. So, and they do have circulation areas in places like that where you go down aisles, so you can pick up merchandise. So let's go down. This is the bridge that we're going to look at. And so, where are we at? So if you never designed a bridge before, if an architect never designed a bridge before, they would look at several bridges, probably like 10 of them, and they do a case study. And um, bridges, they'll look at them for particular desired outcomes, meaning they want particular things for a bridge. So they could be either more aesthetically pleasing. That you're going to hear that a lot in architecture because architects like to use fancy words. This is a fancy word, basically saying that it's style. Um, it looks pleasing. So aesthetics is more of basically how it looks, and so how it's style. It's the words escaping me. How beautiful it is and stuff like that. So that's what that is. They're also going to look at functional things, um, functionality of a bridge. So what is the function of a bridge? You know, it's typically to um, get either pedestrians or vehicles from one side to another, um, because you normally wouldn't be able to do that without a bridge, like cross a river or go from one mountain to another, um, stuff like that. So, and I'm thinking of like a train going from one mountain to another and traveling through the country. Um, so anyway, it's needed. Study is needed, and study of design is needed in such a way that if you want a design to feel amazing or enjoyable, I would have to find a design where that was successful in creating this. So architecture is an art form. When architects design, typically they have the human experience in mind. And so when we look at great architecture, um, a lot of us initial response are that of wonderment and wow. It's like there's huge wow factors and trying to understand, well, who could come up and create this, you know, thing that nobody would normally create. Well, architect did, and they had that in mind. So it should architecture should evoke some sort of emotion. Like when you walk in a kitchen, you should feel, some sort of warmth, some sort of loving, nurturing feeling that someone's going to feed you, or you're going to feed yourself really good because you're going to cook up something nice. It shouldn't feel like a grimy bowling alley. Or, think about some of the spaces you've walked into and you have this automatic feeling. I know when I've walked into a few cathedrals and I'm looking up at, this amazing church and I'm like, oh, I probably should confess my sins. Like that's the feeling that I got when walking through there. So architects did that. They know how the human psyche works and psychologically how people respond to certain things in different spaces. And so higher ceilings and bigger windows. And so when you walk into like a museum or something like that, you get that feeling like, wow, this is really nice. And you kind of want to be on your best behavior. So, or at least I do. So the most successful architects know this, and this is a purposeful design. Um, And the reason why I'm singling out architects, engineers can design as well, but architects, this is what they train for. Architects use engineers to help prove mathematically their structure will stand. And not only that, but come up with solutions to how to construct these designs And so that's how they complement each other. The architect comes up with the design for the spaces and makes sure the human experience is to be had, where the engineer comes up with different solutions to how it's going to be built, and be able to withstand, the natural elements. In California we have earthquakes, so that's one natural phenomenon that our buildings have to withstand, and we have to engineer for that. We also, in our country, we have other states that go through different phenomenons. Florida, for example, they have hurricanes, and so they have to engineer their buildings so they don't fall over during a hurricane. Um, and they have to deal with that. Some areas deal with a lot of snow, and they have to engineer their buildings and design their structures for a lot of snow. You can't have a lot of snow built up on top of the building because too much weight will collapse the roof. And so, these are a lot of things that over the test of time, people that have built structures kind of just figured out. We are at the front end of history when it comes to the technology of building and designing structures for us to live comfortably in. Um, so here's what we're going to do with our case study. So we're going to put our case study together. Um, is we're basically going to create like a vision board, um, and we're gathering ideas and inspiration from various projects that have been completed. The beauty about this is sometimes you can come across things that you've never thought or imagined um, would be out there. So you can get other ideas from um, things that have already been done. And so you can either refine it or change what's already been done and make it your own. Or you can kind of, do a mashup of a design from this architect and a design from that architect, and kind of mash up together a structure that, makes a lot of sense. So things that, architects and engineers have to consider are weather, traffic, sun paths, seismic activity, and many other things. Documenting it all through the case study is pretty much how architects do preliminary portion of the design. And so, nothing's forgotten. And so that's what we're going to do. So section A, I know it says you study their works by reading the project, start with crediting them. What we're going to do is we're going to read these articles. And I forgot to put the main bridge on here, so I'll go ahead and post that up. The main bridge that we're going to study is the Pasadena Bridge, and I'll go ahead and put that up right